Welcome to homework.
We're asked to show that each of these recursive definitions of a function on the set of positive integers doesn't produce a well-defined function. So in part A, we have the recursive definition for a function f is that f of n is equal to 1 plus f of the floor of n over 2 for n greater than or equal to 1 and f of 1 equals 1. Now, we have that f of 1 by definition is equal to f of 1, but we also have that our basis step is not the only thing that's equal to 1, because we have that 1 is also greater than or equal to 1, so it follows that f of 1 is equal to 1 plus f of the floor of 1 over 2, which is equal to 1 plus the floor, or 1 plus f of 0. But we have that f of 0 is not well defined. So it follows that f is not well defined. In part B, we're given that f of n is equal to 1 plus f of n minus 3. For n greater than or equal to 3. F of 1 equals, n greater than or equal to 2. And we're given that f of 1 is 2. And that f of 3, or f of 2 is 3. Now, on the one hand, we have that f of 2 is given as 3, but we also have that 2 is greater than or equal to 2, and so it follows that f of 2 is also equal to 1 plus f of 2 minus 3, which is equal to 1 plus f of negative 1. But f of negative 1 does not exist, and therefore it follows that f is not well defined. In part C, we're given that f of n is equal to 1 plus f of n over 2. For n greater than or equal to 2. F of 1 is equal to 1, and f of 2 is equal to 2. We have that, on the one hand, f of 2 is equal to 2, But since 2 is greater than or equal to 2, we also have the f of 2 is equal to 1 plus f of 2 over 2, which is equal to 1 plus f of 1, which is equal to 1 plus 1, or 2. So that checks out. So it follows that f is well defined for n equals 2. Now let's consider n equals 3. So technically f is defined for it. So 3 is greater than or equal to 2, and so f of 3 is, by definition, 1 plus f of 3 halves. But we have that f of 3 halves does not exist, since f is only defined in integers, and non-negative integers. So it follows that f is not well defined. In part D, we're given that f of n is equal to 1 plus f of n over 2. N is even, and that f of n is equal to 1 minus f of n minus 1 for n odd. And we're given that f of 1 is equal to 1. So we have, by definition, that f of 1 equals 1. But we also have that 1 is odd, and so f of 1 is also equal to 1 minus f of 1 minus 1, which is 0. Now, 0 is even, well, actually, f is only defined in the set of positive integers. So it follows that f of 0 is not well defined. And therefore, f is not well defined. In part E, we're given that f of n is equal to 1 plus f of n over 2 for n even. And f of n is equal to f of 3n minus 1 for n odd. And n is greater than or equal to 3. And we are also given that f of 1 is equal to 1. So we see that f of 1 is clearly well defined. If we were to plug in, because 1 is odd, we get that f of 3 times 1 minus 1 is f of 2, is f of 2 mistake. So f of 1 is well defined. We have that f of 2 is equal to 1 plus f of 2 over 2, which is f of 1, which is going to be equal to 1 plus 1, or 2, is also well defined. F of 3 is equal to, since 3 is odd and greater than or equal to 3, f of 3 times 3, which is 9, minus 1 is 8. And since 8 is even, this is equal to 1 plus f of 8 over 2, which is 4. And since 4 is even, this is equal to 1 plus f of 4 over 2 is 2, which we calculate to be 1 plus 2, which is equal to 4. So f of 3 is also well defined. Now, f of 4, since 4 is even, is equal to 1 plus f of 4 over 2 is 2, which is 1 plus 2, which is 3, which is well defined. And finally, let's consider f of 5. So 5 is an odd number, and it's greater than or equal to 3. So this is equal to f of 3 times 5 minus 1, which is 15 minus 1, or 14. And this is equal to, since 14 is even, 1 plus f of 14 over 2 is 7. And since 7 is odd, this is equal to 1 plus f of 3 times 7 minus 1, or 21 minus 1, or 20, which is equal to, since 20 is even, 1 plus f of 20 over 2 is 10. And this is going to be equal to 2 plus, and then 10 is even, so this is 1 plus f of 10 over 2 is 5. 3 plus f of 5. So we have f of 5 is equal to 3 plus f of 5. So that 0 is equal to 3. This is clearly a contradiction. So it follows that f of 5 is not well defined. And so it follows that f is not well defined.